Hello viewers, welcome to Unacademy YouTube, India's topmost teaching and coaching platform. Today we are going to discuss the important concept of capacitor. Once again, I welcome all the viewers and the aspirant who is looking for Karnataka Common Entrance Examination 2021. Hello viewers, myself R.Vetrivel, Unacademy Plus educator. I have been in this field for the past 28 years. So I am here in Unacademy platform to give you the best basic concept of physics which are very much useful for all the competitive examination. Right? Before moving into our concept, just I appeal all the viewers, the best online platform coaching at the moment is none other than Unacademy. The plus subscription best plan for Karnataka CET 2021, right? There are 12-month and 6-month and 1-month plan is there. Complete batch for live, complete syllabus preparation. It is affordable price. That is the most important one. It's affordable price, structured live courses, quizzes at regular interval, batches for complete preparation, right? Everything under single subscription for unlimited access. Use my code VETRILIVE to subscribe Unacademy and enjoy the unlimited learning. Right? So today I am going to explain the important concept of capacitor. Right? First, let us see two main concepts I am going to explain you today. Infinite ladder network and multiple capacitor and symmetric circuit. Right? Okay. First, let us go the first concept of capacitor. This is multiple capacitor. Right? Here you see that we all know, just I want to remind you, we all know that capacitor C equal to Q by V. Right? Capacitor is a device used to store charge. The ability of the capacitor to store charge is called its capacitance. Capacitor SI unit farad. Right? Capacitor, different types, parallel plate capacitor, spherical capacitor. Right? So the parallel plate capacitor, the capacitance of parallel plate capacitor will be epsilon naught A by D. Right? A area cross section of the plate, D distance between the plate. Right? We know this all. Today concept is, if here you see that first numerical, find the equivalent capacitance between point A and B if the capacitance between any two plates is C. See here, there are n number of capacitors are connected between A and B. Right? There are total, see here, there are total n minus 1 capacitors are connected in series. In this circuit, you can see that there are n minus 1 capacitor are connected in series. So the capacitance between any two plates is C. Between plate 1 and 2, capacitance will be C. Similarly, between 2 and 3, capacitance C. It goes on. Right? Find the equivalent capacitance between point A and B. That is the question. We know that capacitance connected in series, capacitance connected in parallel concept we all know. If there are n number of capacitors connected in series, then equivalent capacitance will be 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3 etc. to go on. If n number of capacitors are connected between the two junctions parallelly, then the equivalent capacitance will be C equal C1 plus C2 plus C3. We know that concept. Here you see that n number of capacitors connected between the two points A and B. Each capacitor is C. That means capacitance between any two plates is C. So there are total n minus 1 capacitor connected in series. So what is the equivalent capacitance all connected in series? So 1 by C equivalent equal 1 by first capacitor C plus 1 by second capacitor C, all is given C. So it goes on etc. up to n minus 1 capacitors, right? N minus 1 times, right? Since all connected in series. Now 1 by C equivalent equal, right? There are C, that common denominator C, right? N minus 1 times, that's it, right? Therefore 1 by equivalent capacitance, we want only C equivalent. Equivalent capacitance will be reciprocal, right? C by n minus 1. Since 1 by C equivalent equal to n minus 1 by C, C equivalent equal, right, C by n minus 1, right? So this is, keep in mind the concept. If n number of capacitor connected seriously, right, then this is the formula. Equivalent capacitance will be C by n minus 1. Let us go for the next concept. See here, find the equivalent capacitance between A and B. This is multiple capacitor, right? Multiple capacitor. There are many number of capacitor plates are arranged, right, parallelly. We all know parallel plate capacitor, right? Parallel plate capacitor C equal epsilon naught A by D, right? When two parallel plate capacitors, see that parallel plate, positive, negative, right? Distance between the two plate D, then we know that derivation of parallel plate capacitor epsilon naught A by D. Here you see that find the equivalent capacitance between A and B, right? Whenever such a problem given like this plate, right, multiple plates are given, immediately you can go for put the number for the plates, right? Just you can put the number on the plates, right? Here is number 1, first plate, and this is 2, it is third plate, it is fourth plate. Just give the number immediately and, right, give positive and negative terminal to the both point A and B, right? So immediately whenever such a problem given, first step, put the number for the plate and either end, both terminal connect to the battery, right? Assume, just you need to assumption, right? Connect to the battery, positive, this end will become positive, so this plate will become positive plate, right? See that either side it will become positive plate, and B plate is here given negative, so this plate will become on either side negative, and A plate, right, third plate is positive, give that positive plate immediately, charge you can give it, and B plate connected to fourth one, so either side it will become negative. Then see here, first plate number 1 and 2, positive, negative, so it will be one parallel plate capacitor, and 2 and 3, positive, negative, this is, there are second parallel plate capacitor, and plate 3 and 4, positive, negative, so this is third parallel plate capacitor, right? So here between the 2 point A and B, the three capacitor plates are connected in parallel. That is the concept, right? How it is connected, you have seen that. Plate A, it is both plate we are giving positive, right? So it is positive, and plate B, see here, this is plate B, we are giving negative terminal, negative charge, so positive negative, this will be capacitor 1, and again negative positive capacitor 2, it's capacitor 3. All you see that plate connected between the two terminals side by side. So this you can simplify as, right, how can you redraw on this, right? From plate A you can start positive charge. See that plate 1, it is positive, right? First plate, and it is with the second plate of B, right? Second plate negative. So 1 and 2 form one capacitor. Next to see that this plate A, third, right? See that plate A, right here, number 3, plate 3 and 2 in this plate B, 2 and 3 form positive negative, another capacitor, and again you see that the 3 in A, right, the 3 third plate positive joined with fourth plate, right, that is B, right, so positive negative. Now see that between the two junction, 2 point, all the 3 capacitors are connected in parallel. We know that when 3 capacitors connected in parallel, what is the equivalent capacitance? Equivalent capacitance will be when 3 capacitors connected in parallel, we know that vector sum of all this, C1 plus C2 plus C3, that's it, where C is here, epsilon naught A by D, since parallel plate capacitor, right, all, right, C1 plus C2 plus C3, that's it, right. If suppose all the capacitance are C, then you will get 3C, right. C is epsilon naught A by D. So this is find the equivalent capacitance between A and B. I have taken, immediately give the number plate and apply positive negative terminal. That means A and B 2 point connect to the battery, right. Then charges you note down, then you know how many capacitor, how it is connected. So since I have taken first capacitor C1, second capacitor C2, C3, all 3 connected in parallel, so effective capacitance or equivalent capacitance or net capacitance will be C1 plus C2 plus C3, right? Yes. Let us go for the next one. See here, find out equivalent capacitance between A and B. Same method, right? First step is we need to give, right, number to the plate. It is one first plate, second plate, third plate and fourth plate. Then two terminal A and B you connect to the positive negative, that means connect to the battery or cell. It will be positive and it is negative, right? Then positive these plates, right, both will be positive, and B this will be negative on both sides, right. B this side also negative on both sides, right. And the fourth plate from A, positive terminal, right, apply positive. Now you can see 1 and 2 plate, positive negative, always capacitor, parallel plate capacitor will be always one positive, one is negative terminal, right. Distance between the two plates small d. So here positive negative, so this is capacitor 1, C1, first capacitor, one capacitor formed here, right. Next, negative negative, so there is no capacitor here, similar charges, and last one come negative positive, so there are other capacitor C2, second capacitor. Now in this case only two capacitors are connected between A and B side by side parallelly. That's it. Right? So this can be redrawn as modify the circuit now. Right? First step, give the number to the plate. Second step, apply positive negative terminal. That means the both end connect to the cell or battery. Then you will come to know, right, how many capacitor formed. Here there are two capacitor, middle one negative negative similar charge, so it is not capacitor, right? So two capacitor are connected. See that from A, right, the first plate, see here, first plate number 1, first plate and second plate of the negative, right, this is the terminal B, second plate of negative terminal. Then see again from A, this side fourth plate, right, it is fourth plate positive joined with third plate of the B, so it is third plate, right, positive negative, that's it. So what happened now? Two capacitor connected between A and B parallelly, right? When two capacitor connected in parallel, what is this is C1 I taken, this is C2. What is the effective capacitance now? Right, when two capacitor connected in parallel, C equivalent or C net equal C1 plus C2, that's it. Right, yes. Let us go for the next one. Find out the equivalent capacitance between A and B. Here you can see A and B, the two. Immediately I told you put the number 1, 2, 3, 4 plates, right? Then A give positive and B give negative of the battery supply connected. So A positive, these two sides will become positive, right? So this positive induces an opposite charge, negative, right? And this side also, this positive induces an opposite charge, negative. And plate B, the fourth plate is already we are giving negative, so both side it will be negative, right? That's it. Now, right, I am taking another one point I consider for our understanding, point C. Now see that plate 1 and 2 positive negative, right? So capacitor 1, first capacitor, and second you come plate 2 and 3 positive negative, so there is second capacitor C2, clear? And come to the third one, see that positive, right, negative, so C3. Now three capacitors are formed, correct? Now how to modify the circuit, that only important. See between the 2 points, now see that, right, plate A and you take it as a common point C. Now between C and A, these two, that means plate 1 and 2, 2 and 3 are connected in parallel, side by side, right? And then between the point C, that means this plate, third plate and fourth plate are in series along with this. These two are C1, C2 are in parallel with C3, right? How to modify this, right? Let us see now. See that, right? Modify this diagram now. This is a plate, point A. From that, see that first one, 1 and 2, right? This is from A, second plate, right? Second plate forming with the first plate. So from A side is a plate 2. First plate is from point C. So this is the first plate. This is the point C, right? Between C and A, now this plate form. Now from A, second plate common, right? And third of the C point. So what happened? These two, see here, same second plate from A forming with third plate of C, right? So these two are in now parallel. Now come to the third capacitor. Third capacitor, you can see that from C, see that from C, third plate. So from C, it is plate 3, right? And plate 4 of B, right? This is plate 4 of B. This point is now B. That's it. Now just you have to simplify. That's all. Over. Now you can see that this capacitor C1 and C2, right, are in parallel, and C3 are with this in series. If you take each capacitor as, right, if you take each capacitor as C only, right, first capacitor, it is second capacitor, it is third capacitor, all as C, right, that is C, it also capacitor, it also all equal capacitance assume. Now, right, capacitance C, 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 first two are in parallel. Parallel mean what is the effective capacitance? Now, see that equivalent capacitance equal, first two are in, the first two you can see that, right, first two, yes, first two capacitor are in parallel. So C plus C1 plus C2, right, we need to add equivalent capacitor. Two capacitors connected in parallel, then just equivalent capacitor will be C1 plus C2, that's it. Then this is with C in series, then C1 into C2 by C1 plus C2, right, that's it. Directly I am doing. So these two are in parallel. So C1 plus C, C plus C, right, and that 2C is with the C in series. So C1 into C2, when two capacitors connected in series, effective capacitance will be C1 into C2 by C1 plus C2. Go ahead now, you will get, right, do that, C and C, 2C into C, 2C square by this is 3C, that's it, C cancel, you will get 2 by 3C, right, this is the effective capacitance between A and B, right, yes. Let us go for the next one. Yes, Unacademy Plus, it is the #1 online teaching and coaching platform in India. There are 20 topmost educators from Karnataka, right, 10 plus batches, 250 plus courses, 2000 lessons, and many more added every day, right. So it is affordable price, right, structured live courses, right, and dedicated live doubt clearing session, quizzes at regular interval, everything under single subscription, unlimited access. So use my code R.Vetrivel and subscribe Unacademy. You can able to watch the topmost lecturers on the platform and PCMB non-stop 24/7, either live session or recorded classes, right, plus subscription classes, right, free special classes and YouTube channels, everything you can watch and benefit more. So no need to delay, all viewers, use my code R.Vetrivel and subscribe Unacademy, right. Okay, today's we are discussing capacitors, right. Now find out the equivalent capacitance between A and B. If such a problem is given, right, in exam they will give you capacitance value, they will ask you to find equivalent capacitance between A and B. In this case you can see, I told you that first what to do, you need to first step give the number, all the plate, right, give the number and this connected to positive and connected to negative, that's it. Now all will be see A positive, it induces opposite charge, it induces opposite charge here, it induces an opposite charge here. That's it. B, see that on both sides it is negative charge we are supplying. Right? It induces an opposite charge. That's it. All now. See here, positive, negative. So capacitor 1, first capacitor. See here, positive, negative, another capacitor, positive, negative, another capacitor, positive, negative, another capacitor. There are 4 capacitors connected. See, I have taken for understanding another point C. Now between A and C, see that these two, right, upper side, see that 1 and 2, 2 and 3 are in series, right, and 3 and 4 are in parallel. First understand between A and C how it is connected, see that, right, the simplified diagram I can show now, then easily you can understand, right. See that now this can be simplified as, right, from A point, see that first from A point, plate 3 and 4, 3 and 4, this is C. Now 1 and 2, right, and one and 2, see that 2 and 3, this is 1 and 2, it is 2 and 3, both are in series, right, and these two are with 3 and 4 in parallel. Then from C come to last one, B, 4th and 5th plate are in series, that's it, this is B, right, this is 4th plate, it's a 5th plate. So it can be redrawn as, now we know all capacitance are C, right, everything capacitance will be C. Now see, these two are in series, then with that C in parallel, and with that answer and this C in series, that's it. All you can simplify, similar way you can do that, you will get, right, the correct option 3/5C. Right, equivalent capacitance you will get. See here, these two are in series and with that parallel, right, and these answer with this C in series, you will get 3/5C, right. We did similar model, have a check it now. Let us go for the next one. See here, there are 5 similar condenser is nothing but capacitor. Each plate area are placed at equal distance apart, connected to the source EMF here. This is EMF. The charge on the plate 1 and 4 will be, right. These first we need to draw, right, from equivalent circuit diagram. Charge on the first capacitor, how will you play? Immediately this is positive side, right. All this plate will be positive. This will be negative. See, that side will be negative. This side positive. Supply now. This you can be redrawn as, right, you can redraw this, you will get, see, first plate and second plate, right. Similarly all the 4 capacitors, see 1, right, 2, 3, 4 capacitor you will get, all connected between the 2 terminal parallelly, right. So this, all the 4, see that connected between, right, positive and negative, 1 and positive, 1 and negative, all the 4 capacitors, see everything is, right, plate you can give the number, you will understand, 1 and 2, next this is 3 and 2, and this will be 5 and 4, and the last one will be 3 and 4, see that. You will get all the 4 capacitor connected in parallel, right? That's it. Now what is the charge on the first plate? We know capacitor C equal to Q by V. From that charge Q equal to CV. C, we know that capacitance of the parallel plate capacitor epsilon naught A by D into V. This is charge on the first plate. And the question is charge on the fourth plate. Fourth plate, you see 2 are there. Understand? charge on the fourth plate Q dash equal, right? You can see that C into potential is, see here positive first plate, right? Here fourth plate is negative potential. So C into minus V minus what is C parallel plate capacitor epsilon naught A by D into V. But here since two plates are connected, so charge on fourth plate, since it has two plate, 2Q dash, that's it. So 2 into minus 2 into same epsilon naught A V by D. This is the charge on, right, this. Now ladder problem, see here, this is the what we'll call infinite ladder circuit. Find the equivalent capacitance between A and B. Whenever such a problem given, infinite ladder circuit, you always see that the circuit has infinite, it is connected to repeated again, right? Up to infinity, repeated capacitor is connected, same capacitor. So that is why it's called infinite ladder network. Since it is infinite network, the effective capacitance does not change even if you remove one setup. That means one system, this one, see between the 2 points, if you remove or you add, right, nothing will happen for effective capacitance. So here what to do, see that C repeated. So we'll take between the 2 points C and D, right, between the 2 points C and D, I am taking effective capacitance as X. Since it is repeated, right? So this I can redraw now. A, this is capacitance C, and here you see that this is capacitance C, it is B, right? This I am connecting as X, equivalent capacitance, right? That's only between C and D. Now I connected this closed as a equivalent capacitance. Since it is infinite circuit, ladder circuit, repeated the same one, so you can close it, it won't affect that equivalent capacitance, right? Now what is the equivalent capacitance between these two, E equivalent and C? You can see that now E equivalent and C, these two are in parallel, and with this C it is in series. Now find out between these two equivalent capacitance and C, right? So total equivalent capacitance in the circuit, these two are in parallel. Parallel in the sense we need to add C plus C equivalent, right? And this C is in series. So into C by C plus C equivalent, right? C1 into C2 by C1 plus C. That's it. Right, simplify, right, this is the answer. These two are in parallel, so C1 plus C2. Then between A and B, this is in series. That's the answer, right? So similarly we can do practice as given here. You can see that here 2C, here 4C, right? Here you see that C next to 2C, 4C. So what happened here? If I take the 2 points, see here C and D, 2 points if I take, it is repeated twice, right? After point C and D, right, the capacitance will be 2x, because at every capacitance become 2 times as compared to AB. C here 2C, next it will be 4C, next it will be 6C, 2 times. Rho, I can, right, simplify this circuit. This is C, right? It is also C capacitor, and it is B, right? It is, now I can complete this C point, and this is point D. So this I have taken as 2x, since it is repeated twice, right? 2 times, because every capacitance become 2 times compared to AB. That's why I closed now. Now we know that simplify 2x and C are in parallel and C are in series. So you will get the same like previous one we solved. You go ahead, you will get that answer, right? Similar, here you see symmetric circuit. Symmetric circuit, this point C and D, about AB, if you fold it, what happened? Since it is called symmetric circuit, C and D are symmetry about A and B, so that C and D can be neglected. That's all. So you can draw this circuit as without C and D. That's it. This is A and B, right? From here, this capacitor, this is C. From here, draw that. That's it. So C and D are symmetry with AB. So CD neglected. Then we know that these two are in series and these two are in series. Now all the three will be in parallel, right? You can do that. You know that formula. You will get answer correctly as 2C. Here C equivalent, finally you will get 2C, right? Then same symmetry model, this also. Find the equivalent capacitance between A and B. Here C and D are symmetry about line AB. So these two will be neglected. That's it. So without this you can draw now A, right? This is C, this is the point B. From here it will go one capacitor, that is point C. From here another capacitor. Between C and D, right, this is point D. That's all. So this is symmetry. CD symmetry about AB neglected. Now these two are in series. These two are in series. These two are in series. Now all the three will be in parallel. So you will get equivalent capacitance will be 3C by 2. Have a check, right? So this is just now ladder circuit I showed you. Now what happens, see here, if you take, right, 2C, again see that repeated, C in the middle, infinite ladder circuit. So if I take the point between, right, C and D, here you can close it. It is repeating again 2C and C. So take the point C and D. Now effective capacitance you take it as, right, X. This can be redrawn as infinite ladder circuit. See that? Right, infinite ladder circuit. From A, right, this is middle, only one capacitor, and this is B, and here it is repeating again, right? So 2C, right? Then this is equivalent capacitance, right? C equivalent, or you take it as a X, right? Close it, that's it. Since it is repeated again, 2C and C is repeating again, so close it now. These two are in, now see 2C and C or X you can say. This equivalent capacitance I can say X. 2C and X are in series. Then what is the equivalent capacitance? Both are in series, right? And then with the C you'll be in parallel. That's it. You can go ahead, simplify, right? These two are in series. So C1 into C2 by C1 plus C2, right? You will get. Then it will be further simplified as from A only this capacitor will have A and B. And here you simplified this, you have, right? Now these two capacitors are between A and B are in parallel. That's it. Go ahead, add both 2CX by 2C plus X plus C, you add, cross multiply, you will get one quadratic equation, right? You will get the quadratic equation. When you cross multiply, you will get X square minus CX minus 2C square equal to 0. This quadratic equation you simplify and you will get X as 2C, right? This is all about today's session. Today we discussed, right, symmetry problem and infinite ladder circuit, right, and multiple plate capacitor. I hope today these three basic concepts repeatedly will ask all the competitive examination. I think this will be very useful to you, right? Champion Patch, Karnataka Common Entrance Examination. Learn from the best educator. Champion Patch is currently going on. So detailed explanation with each and every topic for better understanding, complete syllabus coverage. right? So use my code, all viewers, Vetrivel, and join, subscribe Unacademy. Surely you will be the topper in KCET 2021. With that, I am Vetrivel, Unacademy Plus Educator, signing off from you all. We'll see you the next session. Till then, have a nice day. Bye.